think we're live.
Okay. Cool. So we're live now. Hey, everyone. This is Sibe from Dora Hacks. Thank you all for joining us today for the applicant demo session of the Dora Hacks Space Resources and Exploration Grant. Today, we have Jasper Julian, CEO of SpaceGold, with us to present a demo for their project. So SpaceGold aims to make space resources available to support life on Earth and expand life in outer space. Their groundbreaking venture involves mining in space at a fraction of the cost compared to terrestrial methods, thanks to the exceptional ore quality and the vacuum in space. So we are very excited for this demo today. But before we kickstart the session, let me give you a quick introduction about who we are and just an overview of our grant's background. So for those of you who don't know Dora Hacks quite well enough yet, we are a leading global hackathon organizer and developer incentive platform. We love to support innovation in blockchain, quantum computing, space tech, and more. And we provide a wide range of toolkits to help developers around the world team up and fund their ideas and projects via hackathons, grants, bounties, etc. And as we are very much committed to supporting innovators in this exciting frontier of space tech, this Space Resources and Exploration Grant is definitely going to be a long-term focus for us. And it's open to submissions year-round, so you can submit your project at any time. We've already concluded 2 rounds previously, supporting some really great projects, so you can check out more details on the grant page. The link is in the description. And in fact, we also just launched a Starship use cases hackathon to empower space enthusiasts and engineers to build solutions on thoughtfully curated 18 use cases and 2 open challenges, considering the powerful lift capacity of Starship. You can also find the link in the description. So yeah, we love to call all the space engineers and enthusiasts out there to join us, and we can't wait to review all of your submissions. Lastly, for the audience during the demo, please feel free to share any questions you have in the YouTube chat room, and I'll make sure to ask Jasper your questions at the end. Now, without further ado, I'm happy to pass the mic to Jasper. Welcome, Jasper. Feel free to start by giving us a brief introduction about yourself before diving into the demo session.
Hi, everyone. My name is Jasper Julian, as Sibe mentioned. Thanks for having me today, and thanks to Dora Hack team for arranging this. So I'm CEO of SpaceGold Corporation, and as mentioned earlier, our mission is to provide resources from outer space to the planet and to the space, so we can extend life on the planet and expand consciousness out there in the space. Our team is combined from engineers and business developers from space industry, mostly with 10 to 20 years of experience in the field. I myself coming from a mining background with around 12 years of experience. We have worked in large organizations like Boeing, Blue Origin, Lockheed Martin, Freeport-McMoRan, and like governmental organizations as well, like NASA and National Lab. So we cover most range of expertise that we need at this initial stage. But before we go ahead and get started about why we are doing space mining, why not doing this on the planet, I see Sibe, you already left, but I had a question from you if you're online.
Yeah, I'm here. Just want to highlight you.
Yeah, so I have a question just before we get started. Do you know the metal called platinum? It's also used in platinum used in jewelries, in tech industry. So it's a precious metal like gold. I think Lots of people probably have heard about it. So to produce 1 tons of platinum, say precious metal, how much CO2 we should emit to produce that 1 ton of metal? What is your guess? Just throw out a number.
Like the percentage?
Yeah, like for producing 1 ton of platinum metal, how many tons of carbon dioxide we should produce to make that 1 ton?
I will just take a wild
Yes.
guess then, as I'm really not from this mining engineering background. I will guess like 1,000 times of that.
Actually, that was very good. I've heard like 1 to 2 tons of CO2 to make 1 ton of like metal, precious metal. The actual number is 20,000.
Okay.
So the ratio is 1 to 20,000. That's how much we have CO2 emission per tons of like metal production, precious metal production. So if we do space mining, these numbers come close to almost zero. And this is just the CO2 emission aspect of mining. We have tons of other environmental damages and hazards that happened in the past in the mining industry and will happen in the future if we could keep doing this. So the first aspect, the most important aspect, is that space mining is much more cleaner. And believe it or not, it's actually cheaper to do mining in space. Lots of people, I see surprised faces when I say it's cheaper. It's actually cheaper because this environment is very hostile for any mechanical movements because of the higher gravities, because of our dense atmosphere. It's very hostile for some of the processes that we can do in the space freely in a vacuum that we cannot do on this planet. So overall, if we want to produce, say, 1 ounce of platinum, today we are spending, these are dollar amounts, I should correct these. We are putting $900 to produce an ounce of platinum, which with space mining, we can reduce this number by a lot to $79 per ounce. So it's way cheaper to do space mining, way cleaner to do space mining. So why we're waiting? That's the reason that we put together this team, and we're putting our effort to make this thing happen. So today we're not going to go into lots of technical details. It's just going to be overall look of what are the opportunities, financial side, mostly environmental side I mentioned. So getting to some numbers, as I mentioned, we can produce an ounce of metal at around $79 per ounce with that cost on the moon and deliver it to anywhere on the planet, to the lunar surface or out there in the space. It's pretty cheap when we're working in high capacity. The capacity of our mining engine is around 2 tons per year. The way that it works, our mining process engine mounts on a rover. It goes on the moon. It finds the potential places that we show it to him and start digging and refines it in our refinery in the rover, and then send it back to the planet or on the sites on the moon, because we're going to work on the northern hemisphere. We're going to have some habitants by 2025 in the southern part of the moon. So we can send that to the southern part of the moon as well, and also in orbit for some usage that I show. So we know Artemis 3 is supposed to land the first human in 2025. That's the NASA's plan at the moment. As soon as they start landing, they need metals to start building base on the moon, tools on the moon, 3D printing tools on the moon. So we have 2 options. First, to send those metals in bulk from the planet, launch, land, mobility on the moon is very expensive. It's gonna cost you around $43,000 per ounce to send metals to the moon and use it on the moon. So a smarter way to do it, which governments actually is pursuing it, is to do mining on the moon itself and then use those metals that they mine there on the moon. So see that this number, $43,000 cost of shipment to the moon. If we do mining on the moon, it's only going to cost us $79. So that's a huge market potential over there. By 2027, overall, governments and private companies, they need 1.5 million ounces of metals on the moon for their operation, which estimately is going to build a $10 to $64 billion market on the moon only. On this planet, there are several metals that are very costly to produce, wide range of metals. Lots of them are even more expensive than gold. They're called REE PGMs, precious metals in general. Overall 24 different metals. So our cost of production is at $79 per ounce. We can sell those at $1,400 to $13,000 per ounce. So there is a big market potential over on our planet as well. Overall, around $180 billion. That was the market size in 2022. Also, another potential market that we're tapping into is the orbital manufacturing. If you heard about microgravity manufacturing, there are some sensitive techs that they need to be produced in the orbit because they're very sensitive to the gravity when you start manufacturing them. So NASA and 36 other private companies are pursuing orbital manufacturing. The metals that they're using for their manufacturing range from $1,000 to $13,000 per ounce. And that is just cost of the metals plus around $170, $71 per ounce for the launch to the orbit so they can have it in the orbit. So it's very expensive to launch something to the orbit and then they start manufacturing in the orbit. Again, at the cost of $79, we can produce those metals on the moon and send it to the orbit as well. And another advantage of our technology is that we can produce basically any sort of metal with the same processing engine that we have that works in space only, like more efficiently, much more efficiently because of the vacuum of space, lower gravity. So this cost is constant for any sort of metal we can find out there in the space. For each of our mining engines, we can produce around $4.6 billion worth of metal in 10 years. And that is for each mining engine, as I mentioned. Total cost for these engines are around $80 million, which bumps up the return to 60x for each engine. So far, we had a long journey since 2019. Started with the idea back then, talked to many people in the space industry, namely Dr. Dante Lauretta, head of OSIRIS-REx mission, the biggest asteroid mission that's been operated by NASA so far. We had an asteroid mission back then, and actually lots of people convinced us to switch to the moon. That's our plan today, moon mining, starting with moon mining, and then switching over to asteroid mining. Also, we talked to Dr. Lindy Elkin, the head of next biggest NASA asteroid mission called Psyche, if you heard about that mission. And she became very excited about what we're about to do, how we're going to do it, and who we are, our experiences. So she introduced us to her lab. We already audited the lab. We already talked to the people in the lab, and actually her best man in the lab. Now he's our advisor, and we already organized some tests in the lab. We're just looking for some funding to complete our tests in the lab and get to our next milestone. So far, we submitted a patent in plasma mining, our core of technology. We're at the technology readiness level of 3, which has its special meaning in aerospace, means we already have done our simulations, some of our mission planning. We already selected actually our mining site on the moon in the northern hemisphere with help of our partner, Lunar Station and Planex. They're MIT graduates. And they're the best people you can find out there to do this kind of analysis for you guys, if you're looking for something like that. Also initiated our planning for lunar surveying and lunar mining mission, and with the help of our partner, Lunar Outpost. Our next biggest milestone is going to be next year, which we already scheduled a launch for our orbital test with the help of Momentus Space. Once we test our prototype in space by 2024, we're going to focus on our mapper on the moon, which we call it Moon Metrics. So it's going to be a small rover landing on the moon, start mapping an area of around 3 square kilometer each year. So we have more details on our mining site. And then in 2027, we should be ready for our actual full-scale mining operation. By 2030, we are ready to, if everything goes well, we're ready to go IPO and start our asteroid mining mission. So if you guys have any questions, any area that we can help each other with, any sort of partnership potential, feel free to reach us. We are all on LinkedIn. You saw our team. You can reach directly to me or any of my team members. You can also email me directly at jasper@spacegold.online. Also, feel free to visit our website to get more information about what we're about to do. With that, I take any questions.
Great. Thank you so much for the demo. I actually have a couple of questions for you while we have you here. So my first question is, what are some of the main challenges you and your team have faced during the past few years, and how did you overcome them?
Well, when you start a new venture, especially in something like space mining that is very new, there's so many challenges for, I think one of our initial challenges was that I had to keep up with, get to know more about, my background is in mining industry, so I had to get to know more about the new frontier space industry. Keep up with all the technical news, what technologies are available. Also, from the business side, we had to improve our skill sets because we started as engineers, not business owners. So we had to learn those skill sets as well. So interaction between our team, most of our team, they were in space industry, but they didn't have any experience in mining or space mining technology. So we had to educate each other, just keep up with all the knowledge, overall knowledge that we have in space and mining. So that interaction sometimes was challenging, very difficult to catch up with tons of knowledge in a short period of time. And then I think the most important part was that business knowledge that I personally were lacking at the beginning as an engineer only, as a tech developer, which I learned during all these years that I should develop that business aspect as well and strengthen that. That's one of our strongest skill set at the moment, actually. So that challenge actually became an opportunity for us today. You don't find many people that they have 5 years of experience developing technology and business in space mining. So that's one of our strengths today.
Yeah, thank you. Thank you for the explanation. I'm so glad that you guys managed to turn all these challenges into opportunities today, and wish all the best for you in the future as well.
Thanks.
And I do have another question is, would you mind, or if you could please sharing a bit more about the landscape in the field of lunar mining or space mining in general?
What information? What do you mean by the landscape? Is
Like
very
the competitive landscape, like do you know if there are any other companies working in the same field, or what are your advantages of compared to them, or just as far as you know, like if there are any other companies out there doing similar thing?
there are actually some companies that are pursuing space mining, and for this case, moon mining. There only one company that they passed their seed. They collected a good seed funding, $30 million, Astroforge. And actually, they started after us, and they adopted our initial business model and technology. So I think the competition is gonna be with them, but they're going after the asteroids. Since we developed this, we actually evolved this into moon mining, and we had a reason behind it. The same way that we had a reason that we have to start asteroid mining. So I think uh, understanding the why and how, which was very challenging for us, which we spent lots of time on it, now is our competitive advantage to do maneuver, to change our business model, to look for what is right, not just going there out there aggressively and taking very high risks. So that is like the skill set, the knowledge wise, which we've been taught with hard lessons in the past 5 years. I think that's one of our most competitive advantage compared to, say, Astroforge. And they're using our technology, same technology that we developed like 5, 6 years ago. They already tested in the orbit for asteroid mining. I think technology wise, actually they're ahead of us, but because they already tested the technology in the orbit. Operation wise, I would say, I don't want to say technology because I don't know the details about what they do. They don't know all the details about what we do. So yeah, like overall, I think our experience is our most competitive advantage. But the ground that we choose, moon, is our highest actually advantage at the moment as well.
Got it. Sounds good. Thanks so much for elaborating more on that. I will see if there are any other questions coming from the live audience. Okay, just give me a sec. I don't see any more questions coming in. So guys, if you have any questions later on, feel free to reach out to us or to Jasper directly via his LinkedIn or their website. You got the their contact info at the last slide. If Jasper, if you could please turn to the last page so anyone can see your contact. Yeah, feel free to reach out to the SpaceGold team. Also, you can reach out to us as well. We'll ask any questions you have to the team. And I think, yeah, it's a good time to wrap up now. So once again, I want to say a big thank you to Jasper for joining us today and presenting this demo. And I want to mention again that the Space Resources and Exploration Grant it's a long-term initiative from Dora Hacks that aims to encourage innovation in the space sector. We are very excited to have this program in place, and we already see some great projects and promising teams emerging. And we encourage everyone who's building within the space sector to join us. You can submit your project at any time, and our team will review it in a timely manner. And if you want to learn more about this grant program or the Starship use cases hackathon I mentioned earlier, or just Dora Hacks in general, feel free to reach out. You can click the link in the grant page in the description. You can visit our website at dorahacks.io. We do have more space-related content prepared for you, so make sure you follow us on YouTube and Twitter at Dora Hacks, so you won't miss out on any of the upcoming workshops or demo sessions we are about to host. So with that being said, one more time, huge thank you to Jasper for taking the time to join us today. And we really appreciate it. And thank you to all the audience who's with us today. We'll see you soon. Have a great one.
My pleasure, CB. Thank you for having me.
Bye-bye.
All right, bye.